Okay, in today's lesson we're going to be looking at inscribed angles. So let's take a look at some prerequisite skills here. Okay, so the first one they're asking us, what is the measure of angle BCA for this picture? Okay, so we look at this picture and I should see a few things right away. First of all, these two sides are congruent here. Okay, so that means that their base angle should also be congruent. Okay, I also see that this angle right here is 53 degrees, and so I kind of remember that, you know, there's 180 degrees in a triangle, so what I'm going to say is that 53 degrees plus the measure of angle BCA plus the measure of angle BAC equals 180 degrees. Okay, well, since these two angles really have the same measure anyways, I'm just going to say this. 53 plus 2 times the measure of angle BCA equals 180 degrees. Okay, and now I'll subtract 53 from each side to get 2 times the measure of angle BCA is going to be equal to, again, this will give me like 127. And when I divide by 2, I find that the measure of angle BCA is going to be equal to 63.5 degrees. Okay, and so there is my first answer. Okay, and let's take a look at the next one. Okay, the next one they're actually asking for the measure of t, right? Or what's this measurement right here? Okay, and so remember that these two angles form a linear pair. Okay, that is their non-adjacent sides form a straight angle. Okay, so it's 180 degrees. So I can just take 180 and subtract 63.5 degrees from that, and I should be able to get my final answer here. So I just have to do a little borrowing. Obviously, you can, you know, run to your calculator for help if you need to on this one, but I think I hopefully should be okay. 10 minus 5 will give me 5. 9 minus 3 will give me 6. And I'll get 116.5 degrees would be my final answer there. Okay, looking at just a couple other quick math problems here. Just practice with solving equations. So obviously that's going to be a big part of our lesson here today. So I'm just going to distribute here first in my first step. So I'll say 58 minus x is going to be equal to 4x plus 28. Okay, maybe I'll move all my x's to the right side, so I'll add x to each side to get 5x. Maybe I'll subtract 28 from each side to get 30. And when I divide each side by 5, I'll get that x equals 6. Okay, and looking at one last one on the very bottom here. Okay, I have to distribute here first, so I get 2x minus 16 equals 8. Okay, I would then add 16 to both sides to get 2x is going to be equal to 24, and then divide to get x equals 12. Okay, so, you know, this solving equations review might be a good little reminder for some of you guys kind of moving forward here. Okay, so let's take a look at what we're going to talk about today. We will be talking about finding the measures of an inscribed angle, okay, and we'll talk about how we can use inscribed angles and their properties to solve problems. Okay, and obviously some vocabulary that we're going to be using today, first of all, is inscribed angle, also intercepted arc, and we're going to be talking about this word called subtend. Okay, and let's just go ahead and take a look at a little bit of our vocabulary here. Okay, so make sure that you get this down in your notes. It's going to be really important that you guys remember these. Okay, so all an inscribed angle is, it's an angle whose vertex is on a circle and whose sides contain chords of the circle. Okay, so what I'm going to do here is I'm just going to draw a quick picture. Okay, so let's do this. Draw a quick circle here, and now I'm going to draw an inscribed angle that's maybe like this. Okay, so basically, I have one example of an inscribed circle here. Okay, now it says the vertex is on the circle, so the vertex is right here. It's actually on the circle, and the sides contain chords of the circle. Okay, so this is a chord right here. Okay, this is a chord, and this is a chord. Okay, so that is an example of an inscribed angle. Okay, the next thing is intercepted arc. Okay, so the intercepted arc here, okay, it just consists of the endpoints that lie on the sides of the inscribed angle and all of the points of the circle between them. So this is our intercepted arc right here. Okay, again, it just consists of the endpoints that lie on the sides of the inscribed angle and all of the points that on the circle that sort of like connects them. Okay, and then finally, this last word, and we'll be using it here quite a bit today, is this word subtends. Okay, so it says a chord or arc subtends an angle if its endpoints lie on the sides of the angle. Okay, and so this next little visual here, I think, does a pretty good job of sort of describing this. Okay, so it says that angle DEF is an inscribed angle, so the red angle over here is an inscribed angle. Arc DF is the intercepted arc, and we say that arc DF subtends angle DEF. Okay, and there's a few different cases of inscribed angles that we will be going over today. Okay, and so let's go ahead and make sure that we understand this particular formula first. Okay, so this just says the measure of an inscribed angle is half the measure of its intercepted arc. So therefore, the measure of angle ABC is 1/2 times the measure of arc AC. Okay, and we can just see the 3 different cases here where, you know, one of the chords is a diameter. Okay, or a couple different cases where, you know, maybe the chords actually don't even go through the center. Okay, but either way, it's going to be the exact same. Okay, the measure of the inscribed angle is half the measure of the intercepted arc.